Discontinuity video number 8. Let's do this problem. Part A. Okay, let's just a minute. Okay. Consider the following function g defined by g of x equal x squared minus 1 if x is less than 0, x minus 1 if x is included between 0 or equal to 0 and 1, and for x minus 3 if x is greater than or equal to 1. First, as you can see, it's defined for whatever x belongs to R. At 0 we have function, whatever negative numbers are. From 0 exactly to less than 1 we have function, at 1 and more we have function is defined. Determine whether it is continuous on 0, 1. On 0, 1 we know that it should be continuous first at 0, 1 open interval, and since it's closed at 0 I have to study the continuity at 0 plus, right? I have to study the continuity at 0 plus. Is this function continuous at open interval 0 minus? Is this function is continuous at open interval 0 minus? Yes, it is continuous at open interval 0 minus, since g of x is a polynomial. Look, x squared minus 1 is a polynomial, x minus 1 is a polynomial, and 4x minus 3 is a polynomial. And we know that any polynomial function is continuous at any interval in R, since it's continuous over all R. Now we have to study the continuity at the right of 0. So we have to study the limit of f of x as x approaches only 0 plus. It's not f of x, g of x. So its limit when x approaches 0 plus to 0 plus means x greater than 0. X greater than 0, it's in this part over here. So we are studying the part which is x minus 1. We substitute 0 instead of x minus 1. The answer is minus 1, right? And we have to know what is going on at g of 0 directly. G of the point 0 also we find it here, so it's the same. It's 0 minus 1 because we substituted in this part over here, which is equal to minus 1. Since limit of g of x as x approaches 0 plus equal g of 0, so we have limit to the right of 0. This means the function g of x continuous over open interval 0 plus, and it's continuous to the right of 0. This means g is continuous over the open closed interval at 0 and open interval at 1. Let's do another one. Let's do another case. Sorry. G of x this time is equal to 2x plus 1 if x is less than 0, 3x minus 1 if 0 less than or equal x less than 1, and 2 radical x if x is greater or equal to 1. And we need to study the continuity at 0, 1, closed at 1 this time and open at 0. Closed at 1 and open at 0. Let's see what's going on over here. First is f is g of x, or is g continuous over open interval. First we have to study if it is continuous over the whole open interval 0, 1, right? If it is continuous over the interval 0, 1, open interval 0, 1. First on 0, 1, as you can see, on 0, 1 and less than 1, from 0 plus to 1 minus, from 0 plus to 1 minus, open interval. This is 0, this is 0 plus, and this is 1 minus, right? That's it. So it's only 3x minus 1, and 3x minus 1 is a polynomial function, so yes, it is continuous at the open interval 0, 1. We need to study now if it is continuous at 1 minus, closed at 1, means we have to reach the continuity at 1 minus, right? So limit of g of x, limit of g of x as x approaches the 1 minus equal limit of which part? 1 minus means less than 1, so also in 3x minus 1 as x approaches 1 minus, so the answer is going to be 3 times 1 minus 1, which is equal to 3 minus 1, which is equal to 2. And we have to study the g at exactly 1, which is g of 1. When x equal to 1, the g of x is 2 radical x, so it's 2 radical 1 instead of x, so the answer is 2 times 1, which is also equal to 2. Since the limit of g of x as x approaches 1 minus is equal to g of 1, this means that we have left continuity at 1. Left continuity at 1 over here, and it's closed at 1. Since it's continuous over all open interval 0, 1, and we have left continuity, so yes, the function is continuous at the interval 0, 1. That's true. Let's go to another problem. Let's go to this problem. Study the continuity of the function f on the interval 0, 2. On the interval 0, 2 in each of the following cases. Let's say part A. First, f of x is equal to 4x if x is less than or equal 1, and it's equal to 4 if x is greater than 1. We have to study if it is continuous over only the interval, the open interval 0, 2. Let's see. Let's see. First, we have to know if it is continuous, since it is polynomial, right? Since it's polynomial, it's continuous over 0, 2, but what's happening at 1 exactly, we don't know except if we study the case, right? So let's study the case directly. What's happening at the point 1 exactly, right? At the point 1 exactly. Let's see. F of x. It's better to check, right? Even if it is polynomial, we have to check what's happening over, because he could give me two different functions over here. It's piecewise function. All right. So limit of f of x. Limit of f of x. Okay. At x approaches 1 minus what is going on. 1 minus means less than 1, so it's over here. So it's limit of 4x as x approaches 1 minus, so we substitute 4 instead of x1, then it's equal to 4. And limit of f of x as x approaches 1 plus is when x is greater than 1. This means it's over here, so it's limit of only 4 as x approaches 1 plus. We don't have x to substitute, so directly it's equal to 4. And what is f of 1 exactly? Is 4 times 1, which is equal to 4, because we have to substitute 1 over here. Then, since limit of f of x as x approaches 1 minus equal limit of f of x as x approaches 1 plus equal f of 1, then yes, f is continuous at 1. So, and it's continuous at the open interval 0, 2, because it's a polynomial function. At when we say less than 1, this means from 1 to 0. When we say greater than 1, 1 plus, this means from 1 to 2. So it's open interval, okay. The continuity is fine over there. Okay, f of x equal x plus 1, right? If x is less than or equal 1, and it's equal to 1 if x greater than 1. Let's see. Let's see. For sure, it's continuous. Also, we need to see if it's continuous over the open interval 0, 2. Same thing. Limit of f of x as x approaches 1 plus is equal, 1 plus is over here, is equal to limit of 1 as x approaches 1 plus, no x to substitute, so the answer is 1. Limit of f of x as x approaches 1 minus is equal when x is less than 1, limit of x plus 1 as x approaches 1 minus, so the answer is going to be 1 plus 1, which is equal to 2. Then f is not continuous at, is discontinuous at this point, so it's discontinuous at the open interval 0, 2. One more. We have f of x is equal to x squared minus 9 over x cubed minus 27, right? Also piecewise function. If x not equal 3, and again not equal 3 means either 3 plus or 3 minus, and it's equal to k, certain constant, if x is equal to 3. He said determine the value of k such that f is continuous. What is k? Such that f is continuous at x is equal to 3. Since it's continuous, so I know that limit of f of x as x approaches, since it's given continuous, 3 plus, for sure it's equal to limit of f of x as x approaches 3 minus, it's equal to f of 3, right? Let's see what's going on at 3 plus 3 minus. Both the same. Those, we can find them when we substitute 3 over here in this part, because not equal to 3 means 3 plus 3 minus. But we can't substitute, because if we substitute, we're going to get 0 over 0, which is undefined form. So that's why I have to analyze this. F of x is equal to x squared minus 9, which is x minus 3 into x plus 3, and x cubed minus 27 is x minus 3 into, those are identities, right? X squared plus 3x plus 9. Simplifying this, we're gonna get x minus 3 cancel, where x not equal to 3 for sure. So f of x in its simplified form, it's x plus 3 over x squared plus 3x plus 9. That's nice. What is the limit of this x plus 3 over x squared plus 3x plus 9, where x approaches 3, which is either 3 plus or 3 minus, the same, because x not equal to 3. We just substitute, right? It's a 3 plus 3 over 3 square 9 plus 3 times 3, another 9, and plus 9. So the answer is 6 over 27 divided by 3, it's 2, divided by 3, it's 9. 2 over 9. Since those two represents the limit I got, and they are equal to f of 3, and what is f of 3? Simply f of 3 is equal to k, because as x equal to 3, f of 3 is equal to k. And those are equal to f of 3, which is 2 over 9, then k is equal to 2 over 9. We found k. Alright, see you next video.